Okay, so this is my resource for the teaching of the dihedral angle. I've chosen the 3D model in SOLIDWORKS because I think that when students are completing these questions, that the actual visualization of what they're dealing with is one of the hardest aspects of it for students. So I have this 3D model here, and of course we can see it in our views, our tree views. So that's our elevation. We can see it in our plan view, and then of course we can see it from our end elevation as well. So for the teaching aspect of this, the first thing that we're going to have to teach students is about finding the true length of our line of intersection. So with this model, students can actually see what the line of intersection means. So of course, this is their line of intersection. So students can see um, the auxiliary view that we take for this. So when we look in at this direction, this is what we're going to see. So I don't have the points labeled now, but you can see the traces of the construction lines there showing what the actual drawing is showing. So when we take an auxiliary view looking perpendicular to our line of intersection, we get this line in our auxiliary view, which is actually a true length of the line of intersection here. So then the next aspect of this is because we want to see the angle in between these two planar surfaces, we're going to want to take a point view and look at it in this sort of a direction, and then obviously you can see your angle there. So what we do is, from looking in at this point, we'll just call this point A and this point B, we're going to take another auxiliary view looking along this line so that it's projected over here as a singular point. And this is what we end up with, this kind of two-line shape where we have our singular AB point here, and then obviously our C and D points up here, and then this inside here is our dihedral angle. So just to put that in another bit of context, so this is what we're actually looking at. So this is the auxiliary plane, and we've come over here and we have looked normal to this surface, and we get our 3-point view of the object that we're looking at, and then this is our AB as a singular point in that auxiliary elevation.